Okay, this video is going to go ahead and encompass 5.6 and 5.7 because they're so closely related. And we're going to look at graphing inequalities on the coordinate plane. So linear inequalities in one variable. Let's look at this first one. I know it's an x equals equation because it's a vertical line. And the equation is, or the inequality is x is less than or equal to 2. So because it says or equal to, the line is solid, and then you would shade everything to the left that is less than 2. A y equals equation, remember, looks like a horizontal line, but because this says y is greater than -2 and it doesn't say or equal to, then I know that the line is dotted because the line is not part of the solution. And then you would shade everything that's greater than that line. So when you're doing linear inequalities in two variables, so this one is y is greater than 2x plus 2, you go ahead and graph this line, y equals 2x plus 2. The y-intercept is 2, the slope is 2, so you'd go up 2 and over 1. But it doesn't say or equal to down here, so I know that my line is dotted. And it says greater than, so I just took a stab that this is the shading. Now, let's say I'm not really sure where the shading is, so I'm going to choose this point right here, 0, 0, because it's the easiest point to test. And I'm going to plug 0 and 0 in for x and y, which leaves me with 0 is greater than 2. Well, 0 is not greater than 2, so I know that this point is not part of the solution, so it's not part of the shaded region. So if you're confused about which side of the line to shade on, just test a point to see where it is. This inequality is y is less than or equal to -3/2 x plus 1. So I know, first of all, that the line's going to be solid because it says or equal to. And the y-intercept is 1. The slope is -3/2, meaning I go down 3 and over 2. And then it's less than, so I'm going to shade over here. Now, to be sure that I shaded the right area, I'm going to go ahead and test that point again, 0, 0. But this time I want it to be a solution, right? So I'm going to do 0 is less than or equal to -3/2 times 0 plus 1, which gives me 0 is less than or equal to 1. And 0 is less than 1. Sorry. So I know that this point should be part of the shaded region. And that's how you test your points. So that was it for 5.6. So now we're going to talk about systems of linear inequalities. So for example, you're going to get like two equations, like always, a system of inequalities. And I want to know if this point is a solution. So if this point's a solution, it has to satisfy both of those inequalities. Let's test number 1. So x is -2 and y is -1. So that would leave me -1 is less than -2 plus 2. -1 is less than 0. Yes, it is. So that point checks out for the first inequality. Now let's plug x and y into the second one, which would give me -1 is greater than or equal to 2 times -2 minus 1. -1 is greater than or equal to -4 minus 1, which leaves me -1 is greater than or equal to -5. It is greater than -5, so that point does indeed lie in the shaded region if I were to graph this. So yes, it counts, or yes, it works. So let's look at graphing a system of linear equations. And these are the two inequalities that I have. The red, both of these are going to be dotted lines, notice, because it doesn't say or equal to. So this red dotted line is the equation y equals 2x. The pencil dotted line is the equation y equals x plus 1. For the red, I want to shade less than. So you can see where the red shading is. Y is greater than, that's going to be where the blue shading is. And then you want to look at where do the shaded parts coincide. And we can see that the solution is that wedge right there. So any point that lies in this area is going to be a solution to this system. And that is it for 5.6 and 5.7. And we're done with chapter 5.